Hello everyone, my name is Hazal, and now I will present the land use optimization in watershed scale. The article belongs to researchers from Iran. To mention their names, they are Sadeki, Jalili, and Nikami. Managing a watershed for satisfying the inhabitants' demands is a difficult task if one has to maintain a reasonable balance between usually conflicting environmental flows and demands. The solution to these complex issues requires the use of some mathematical techniques to take into account conflicting objectives. And this paper addresses the difficulty of managing watershed in land use scale while trying to satisfy the environmental protection in terms of soil erosion and the economic concerns which are profits from the land use activities at the same time. And the study area, Birimwan watershed, is located in the Kermanshah province, and it is the most dynamic region of Iran in terms of water and energy supply, industrial and urban development, and agrarian activities. Therefore, land use conflicts and environmental issues are also emerging increasingly in this region. Especially soil erosion emerged due to these activities. The Birimman watershed covers 9,572 hectare area. The land use activities are classified as four major activities, which are orchard, rangeland, irrigated farming, and dry farming. They occupy 38.32, 4,001.27, 4,049.27, and 952.97 hectares respectively. And the methodology they used. The problem was structured in the study area to maximize economic return and minimize soil loss. To do that, they used multi-objective linear programming model. The information and data required for defining constants and coefficients of objective functions and for the constraints like land availability, water availability or supply, soil characteristics, slope, steepness, and aspects, present land use, soil erosion, and sediment yields, socio-economical conditions were extracted from the available comprehensive studies conducted for the study area. And also, they use GIS mapping for spatial analysis and ad-based software for optimization. And the optimization model, the objective function is the maximization of benefit while minimizing soil erosion. You can see both objectives. And the first function is economic benefit maximization. And here AI1 represents the annual gross benefits per hectare for land use I, AI2 is for production cost per hectare, and AI3 is for the soil erosion destruction cost per hectare. And XI is the area allocated to land use I, and it is actually the decision variable in this case. And similarly, in the second equation, the soil erosion cost minimization, CEI represents the annual soil erosion rates in terms of tons per hectare for land use I. And the constraints. The first one is the land capability constraints, which are B1, 2, 3, and 4, the maximum allowable areas based on slope, soil depth, and water availability. However, in this case study, the water availability is not such an important concern due to the plenty of water sources in the region, because there are 10 springs with discharges from 2 to about 500 liter per second and 128 wells within the total discharge like 11.2 million meter cube per year in this study watershed. The main irrigation channel of Birimwan Dam with the average discharge of 5 meter cube per second also passes along the entire watershed. So the water is quite sufficient for the region. And X1, 2, 3, and 4 is for the areas allocated to orchard, rangeland, irrigated farming, and dry farming, respectively. The second constraint is a land availability constraint. the summation of x1 to 4 cannot be higher than the total area, which does not include the residential and outcrop areas as well. The third one is social and legislative constraints, minimum and maximum land use areas as dictated by government policies and cultural practices. And here, there is a minimum limit for the orchard and rangeland activities as they are the major economical applications for the area. And of course, the non-negativity constraints, they cannot be less than 0, of course. By using the soil erosion rates, soil characteristic, rooting depths, and soil bulk density, soil erosion impacts, and net benefits from the activities, the coefficients of the objective functions were found, and objectives are formulated as you see. In the maximization economic benefits function, the coefficients are the net benefits, and they are in terms of the million Iranian rial per hectare. And in the minimization soil erosion function, the coefficients are belongs to the soil erosion rates, and they are in terms of the tons per hectare per year. And this slide shows a summary of objective functions and constraints after applying the coefficients. And here you see a maximization. It doesn't make you confused because, it is in minus sign actually. And yes, after applying the optimization, they saw that orchard increased significantly from 38.32 hectares to 518.81 hectares, and beaches 13.5 times larger than the initial area. And dry farming reduced by 50% from 952.97 hectares to 477.19 hectares. Irrigated farming remains stable at about approximately 4,044 hectares. Rangelands maintained at 4,001.77 hectares. And at the same time, soil erosion decreased from 82,910 tons per year to 76,380 tons per year, about 8% reduction. Economic benefit increased from 21,001 million Iranian rial to 24,090 and 911 million Iranian rial, and approximately 19% gain was observed. And this is a summary of the result of optimization, the values of the incomes, net incomes, of total erosions, and etc. And yes, sensitivity analysis. The left-hand side figure shows the sensitivity analysis of benefit maximization function, and right-hand side figure also shows the sensitivity analysis of soil erosion minimization function. And the B1, 2, 3, 4, 5, 6, and 7 are maximum allowable area to orchard, irrigated farming, dry farming, summation of orchard and irrigated farming, or minimum area of orchard and rangeland respectively. For example, for B1, from the left-hand side figure, as you see, when the change is increased for B1, the net income increases as well. Or for the right-hand side figure, for B3, the dry farming, and the change in the B3 doesn't affect the soil erosion actually, because it just remains on the axis. To conclude, after implementing the optimization for land use, it was seen that it is quite effective to achieve the objectives. It has many benefits like environmental benefits by reducing dry farming and increasing orchards, helps minimize erosion due to tracing and improved land cover. Or economic gains, higher income from orchards and irrigated farming drives significant improvement in net benefits. And from a point of feasibility, the proposed changes are achievable within the area's constraints, but require support through education, subsidies, and farmer engagements as well. And thank you for your attention. This is the end of my presentation.